All right, what is the domain of the following function? This is question number 11. It says write your answer in interval notation, and it shows us a rational equation. It's got a radical on top, specifically a square root. It's got a logarithm on the bottom, specifically a natural logarithm. And in order to answer this question, we have to know what the domain is. A lot of us are very keen to say that domain is x. Well, that's not very informative. Domain are the x values that exist within a function. In other words, they are the x values that for each a real y value exists. We should have a real y value for every single x value in the domain. Okay, so the types of functions that you have, the type of operation you have in the numerator, the type of operation you have in the denominator, are going to affect whether or not you have a real y value that corresponds to that. For instance, when you're talking about square roots, the inside of a square root, the radicand, cannot be negative. Because if it was negative, then when you take the square root of a negative number, that's imaginary. And we can't graph real y values if it's an imaginary number up here. Okay. Likewise, on the bottom, a logarithm, the argument of a logarithm has to be positive. It can't even be zero. You can take 0, the square root of 0 is 0, that's fine. But down here, you can't even have a 0. It can't be negative and it can't be 0 because the argument is some number to some power equals the argument. For instance, like x to some power equals whatever the argument is. And if I said x to what power is equal to 0, no such power exists. There's no such thing. Or x to what power is -3. There is no power, no matter what this number is, there's no way to make negative numbers with exponents. So that's why logarithms cannot have 0 or negative in their arguments. Okay, so let's think about what value x can be up here, what value x can be down here, and then we'll talk about how we integrate that as a proper domain. So if x minus 3 cannot be a negative value, but it can be 0, we can say that x minus 3 is equal to or greater than 0, because that covers 0 and all of the positive numbers. Down here on the bottom, 2x minus 27 cannot be 0 or negative. It has to be positive, so we'd have to say it's greater than, not equal to 0. And we solve each of these. Okay, this one's pretty easy. Just add 3 to both sides. X must be equal to or greater than 3 on the top. And over here, it's a little bit messier. We add the 27. 2x is greater than 27. Then we divide both sides by 2. X is greater than 27 halves. If we divide 27 by 2, that's actually, just for the sake of knowing what we're talking about, is 13.5, because 2 goes into 27 13 times with 1 left over, right? So we're saying that all of the numbers on the top have to be greater than 3, and all of the x numbers on the bottom have to be greater than 13.5. Now, are we looking at a union here, or are we looking at an intersection? Okay. In order for this to be real numbers, we are talking about an intersection. It must meet both of these criteria. Okay, so if we go ahead and put some random numbers on this number line, let's go with 3 right here. Oh, they're not random numbers. We found these numbers. 3 right here, 13.5 right here. Let's go ahead and label them. 3 and 13.5. The blue is going to be equal to this, so solid dot, and greater than this, so we shade this way. The x value, the green interval, is going to be greater than 13.5, but not equal to it. So we'll leave it as an open circle and then shade upwards. Okay, so think about this. If I chose a number that was less than 3, then this number up here would become imaginary, which is not allowed. So that's not in the shaded region. If I picked a number that was greater than 3, let's say the number 5, then it would be okay up here. 5 minus 3 is 2, and I can take the square root of 2. It's irrational, but it's real. But down here, if I chose 5 2 times 5 is 10, and 10 minus 27 is a negative number, and that's not allowed. So I can't use this section. I can't use this section. I have to only be able to use the section that is both blue and green. Okay? So that would say that this is really what's limiting the domain. The domain is going to be x is greater than but not equal to 13.5. And if I wanted to write that as an interval, it would be with a parenthesis, 13.5 is the lowest number, and it can go as high as you want it to, all the way up to infinity. That's fine. So this is an answer. If we wanted to put this in fraction form, I don't really care which one you put, but 27 over, I don't know why I did that, 27 over 2 to infinity. Both of these are intervals that can represent the domain, but you only need one of them. Okay? That's how you do number 11.